In this short video, I want to give you some idea of where maximums and minimums occur of functions and talk to you about how we can use derivatives to find these locations. So first, let's think about what do the derivatives look like at each of these points. So you have two portions of a curve here, and you notice I've drawn the red tangent lines. And so in the first one, let me label that as maybe A, and then this one B, and this one C. So in the first one, you can see that the tangent up at the top is horizontal, and so your slope is going to be 0, and your derivative is going to be 0 as well. Let me get this B out of the way. And now in your second one, you see the same things occurring. Your slope is 0, and your derivative is 0, because the slope and the derivative are the same. And then finally, in this last picture, it's a little different because there's what we call a cusp at that part of the function. It's a portion of function that looks like this. And if that's the case, then we have a derivative that's undefined because the derivative is actually, or the tangent line is actually vertical. And if you think about a vertical tangent, tangent lines, slopes are change in y divided by the change in x. And if you have a vertical line, the x's don't change, and therefore you'd be dividing by 0, and that would cause you to have an undefined slope there. So there are three different versions of this, right? The first version is where you have something that's opening down, and there's a maximum at the top. You think of that as hilltop. And the second, you had something that was opening up, and so you have a valley, and then you have a cusp. That could be opening up or down. So, where do these maximums and minimums occur? That might be a good question. How can we tie that to derivatives? So here's a function where I've put all of those things together, and I've kind of put some points on the graph that would lead you to believe that there are some what we call local maximums and local minimums. There's a distinction between local maximum, local minimum, or absolute max and absolute mins, which we'll talk about a little bit later. But a local maximum or minimum just means that if you look at a certain region of your graph, in that region, that's where there's a maximum or minimum. So you could think of a mountain range, and in that mountain range, you look at a certain region, you're just looking for the peak in that region, but there might be peaks that are bigger or smaller somewhere else. So let's kind of look at this. So we've got those points there, and I've drawn the tangent lines. And of course, you can probably see, as in our last slide, we've got some of those slopes that are 0, and then we have a slope that's undefined. And so there, the slope is 0, so the derivative is 0. Derivative is 0 at that point as well. At this point, we have a vertical tangent, so the derivative is undefined. And then finally, at our point there, we have the derivative is equal to 0. Notice that I've also circled the endpoints because if we were looking for maximums and minimums with our eyes, we can actually see that the minimum for this function occurs at the left endpoint, the maximum at the right endpoint, but there are also some local maximums and minimums on the interior of the function. And so what we're seeing from this picture is that it looks like if the maximums and minimums don't occur at the endpoints, then those maximums and minimums then are occurring on the interior points where the derivative is 0 or undefined. So what are critical values or stationary points? So critical values are all the x values where 1, the derivative is equal to 0, and 2, derivative is undefined. And that's what we saw from that last graphic. So if we take a function and find out all the locations where the derivative is 0 or the derivative is undefined, then these are critical values. By the way, a stationary point is just a critical value, and it's the first bullet point. It's the critical values where the derivative is equal to 0. If you think about that, we're calling those stationary points because the derivative of a function is like the velocity. And so if the derivative is equal to 0, it's akin to the velocity being equal to 0, and hence we call them stationary points. But they too are just critical points, or critical values, I should say, since we're just talking about the x. Now there's one thing to remember, that these x values must be in the domain of the function. So we're just saying that these are the x values where there might be what we're calling local maximums or minimums, and those x values have to actually be in a domain of the function. It would make no sense to say that here's an x value where the function has a maximum, and there is no way that you could plug that x value into the function because it's not in the domain. And note that these come from the function's derivative, right? So we're taking a derivative of a function that we're analyzing. So I hope this helps a little bit, and we'll talk more about this in class.